Alright, so in this video, we're now going to talk about how to draw your atoms, okay? And we're going to use the Bohr-Rutherford model, alright? So on the periodic table, atoms exist in what's called a neutral or atomic state, okay? And in this state, what that means is the number of protons is equal to the number of electrons. So this is just a review from your electricity unit. Protons are positive and they're inside the nucleus. Electrons are negative and they orbit on orbitals outside the nucleus. And neutrons have no charge, they're neutral and they're inside the nucleus. So Bohr-Rutherford is the name of two scientists who came up with the theory to draw an atom. And we've already drawn an atom once, but we haven't done it by calculating the protons and electrons and neutrons. So we're going to use lithium as our example in order to go through how you would draw an atom. Okay, so first off, you need to find the number of protons. Okay, we're just going to use P, okay, the number of electrons and the number of neutrons. So it's very simple. Remember from the periodic table that the atomic number, so the whole number, and that is its placeholder on the periodic table, is the number of protons, okay? So for lithium, let's write its name. Okay, so for lithium, this equals 3. All right, now we're drawing lithium in its neutral or atomic state, which means the number of protons equals the number of electrons. So then this also is 3. Okay, now comes the only part you have to do any math at so far, and that's the number of neutrons. Electrons are extremely light and have an extremely high amount of energy. And it's impossible to have no mass, but we say that electrons have such a relatively low mass that it's considered to be no mass. And so when we look at the average atomic mass for an atom or an element, we neglect the electrons from this number. So all that's taken into consideration in this number is the number of protons and the number of neutrons. So each proton and each neutron weighs 1 atomic unit. Okay, and a neutron weighs 1 too. Okay, so that means that this average mass is taking only these into account because we consider this to weigh nothing, even though we know that's not possible. So having said that then, if I know, here comes your friend math again, if I know how many protons I have and I know what protons and neutrons together equals, then I can figure out what neutrons are, okay? So the atomic mass is equal to the number of protons plus the number of neutrons. So therefore, with some simple rearranging, the number of neutrons is equal to the atomic mass minus the number of protons. So the next thing I have to do then is I have to take this number here and it has to be rounded to a whole number. Okay, so in this case, 6.941 is going to equal 7. Okay, so now I'm going to do my simple math to figure out how many neutrons there are in lithium. So I'm going to take 7, excuse me, and subtract 3 from it, okay? So 7 minus 3 equals 4, so there's 4 neutrons in lithium. So now comes the big moment where you're going to draw it, okay? Lots of people have different ways of representing Bohr-Rutherford. So I'm going to show you what I was taught and what I still use. So the nucleus is a solid line that goes at the center. And inside the nucleus are the neutrons and the protons. So you're going to put 3p and 4n. Okay, now this is where your grade 10 teacher might differ a little. I use a dotted line to represent these orbitals that the electrons are on. And I hope you can see that in the video. Now, when you're putting the electrons on, you can't actually just put them willy-nilly wherever you want. You have to give them a specific arrangement, okay? And so in the very first orbital, it can actually only hold 2 electrons. And that has to do with the fact that it's so close to these positives. When we talked about those electric forces during the electricity unit, that's all that can sort of be attracted there, okay? So this is based on energy as well, okay? And the rings or the orbitals that are closest to this nucleus here are the ones that have the lowest energy. The further out you go, okay, so now what's going to happen is, so there's different orbitals. So the first orbital can only hold 2 electrons. We're going to write that down after. Okay, and lithium has 3 electrons total. So now my next electron goes here on this second orbital, okay? So this 3 is now represented by this dot, and this dot. Each of those dots, okay, this equals 1 electron, okay? So there's 1, 2, 3 electrons orbiting. And so this has a maximum of 2, okay? So this first orbital can take 2 electrons, okay? Then the rest, so the second and third orbital, can take 8 electrons, and the third can take 8. Okay? So now let's look at what happens when you have to fill up one of these orbitals that has 8, so that you know how to draw that, because there's a special way to draw that. So, we're going to look at chlorine. Okay, so chlorine has an elemental symbol of Cl. It's number 17, and it has an atomic mass of 35.446. Okay, so you're going to start out by writing down number of protons, number of electrons, number of neutrons. Number of neutrons equals atomic mass minus number of protons. Because we're drawing this in a neutral state, number of protons equals number of electrons equals number of protons. Okay? So I have to remember what each number means. So the whole number, that's my atomic number, and that equals number of protons. Okay, so I have 17 protons. Now, because I'm in a neutral state, I have 17 electrons. And now I'm going to do my math to figure out the number of electrons. So I'm going to take 35.446 and I'm going to round that to be a whole number. So it's going to be 35. And then I'm going to subtract this number 17 from that 35, and I'm going to get 18, okay? So I have 18 neutrons, 17 protons, and 17 electrons. So what does a chlorine atom look like? So I'm going to draw my nucleus, and I'm going to put 17p, 18n, okay? And I'm going to use that dotted line to represent my orbitals, okay? Remember that one of these equals 1 electron. I have to draw 17 now. So I go 1, 2. Okay, I've only done 2, so I still have 15 left. So when you're filling in the second orbital, and it can take 8 as a maximum, I don't just start going 1, 2, 3, 4, 5, 6, 7, 8. What you do is you first draw them as singles, okay? And then you start giving them partners, okay? So at this point in time, let's count the total number of dots I have on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 17 total, so I still need 7 more. So I need another orbital. Okay, and so I go 1, 2, 3, 4, 5, 6, 7, okay? And this electron here does not have a partner, okay? So this orbital is not completely full. And when we talk about ions, we're going to talk about what happens with this. This very last orbital is called the valence orbital, or the valence shell. And the electrons that are contained in this orbital are known as valence electrons. Okay, and again, that's going to be important when we start looking at what do we do with these electrons that don't have partners, okay? So the electrons have a lot of energy, they're moving around, they sort of need to have a partner with them to be happy, in a sense, is how we describe it. Okay, so now, I said earlier that everybody wants to be like a noble gas. And the reason is because the noble gases, if I look at, say, neon, okay, neon's number 10, I think. Let's check. Yeah, it's number 10, and it weighs 20.180. Okay, so let's look at and draw neon so you can see why everybody wants to be like neon, and you can figure out what it is that makes them more stable than the other electrons, or pardon me, not the other electrons, than the other elements. So I'm going to do my number of protons, number of electrons, number of neutrons, and that equals atomic mass minus number of protons. Okay, and now I'm ready to get started. So the whole number, the no decimals in it, is always my number of protons. I'm in an atomic or neutral state, so my number of protons equals my number of electrons. So 10 and 10. Now I take this number, the atomic mass, and I round it to be a whole number. 20.1, and this would round to 2, is going to be 20. So I'm going to have 20, subtract 10 is 10. Okay, and I'm just going to crowd it in on, actually no, I'm going to turn the page through. So now, okay, I'm going to rewrite everything at the top for you. So we've got neon, okay? It's got 10, 10, and 10. So I'm going to draw my nucleus, okay? So 10p, 10n, okay? I'm going to do my electrons. 1 dot equals 1 electron, so 1, 2. I need 10 total. I have 2 there, so I'm going to need to draw another orbital. Okay, and I'm going to start them out as singles, put them on the points of the compass or at 12, 3, 6, and 9 if you can still tell time. And then I'm going to start pairing them up. So wait a minute, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, would you look at that? That entire orbital is full. It can take a max of 8. And there are 8 electrons in that orbital. And that, my friends, is why everybody wants to be like a noble gas, because they come with their orbitals filled to the desired electron configuration. No other family, almost no other family, no other family on the periodic table can do that. And that's why everybody wants to be like a noble gas. So your homework, or your work in class, really, it's not homework, this is your homework. Your work in class is to draw the Bohr-Rutherfords for the first 20. So that would be hydrogen all the way to calcium. Okay, and you're going to have a quiz on this too. So this is your classwork to do this. So if you're confused, you have questions, that's why you're doing it in class. And then we're going to have a quiz on this. All right,